Hello students, I hope you are good, well and fine, and today we will be continuing our discussion on the topic triangles. We discussed the theory, we discussed examples. Now we do some more examples to polish the theory or the concept on triangles. So let's see some exercises or more examples. So the first question says, in the three altitude of a triangle are equal, then my triangle is, if you recall, what triangle is called if all of the three altitudes of a triangle are equal. So in isosceles triangle, the two sides must be equal. Okay, in equilateral triangle, all the three sides must be equal. All sides must be equal. Okay, and in right angle triangle, if you see that the longer side is hypotenuse and the opposite to that side, the angle makes is of 90 degrees. So this is my hypotenuse. Okay, so in this the altitudes are not all are equal. So this gets neglected or just rejected this, and the remaining is this. So if you see that the question is saying that the three altitudes of a triangle are equal, then that my triangle is equilateral triangle. So this properties only holds in the equilateral triangles. Okay, if you try to see all sides, they are equal. If you try to see their altitudes, they are also equal in length. Okay, I hope this is all clear to you. Okay, let's see next question. Okay, so option B was our correct. In a triangle PQR, if you have a triangle PQR, PS is a bisector of Q. Okay, then if let me draw a triangle PQR, so PQR, PQR, in PQR, the angle Q is equals to 70 degree. This is angle of 70 degree. My angle R is of 30 degree. 30 degree. The remaining angle must be, then if you recall, that 30 plus 70 plus angle P must be equals to 180 degree. So this means angle P is 180 minus 100. This means the angle is of 80 degree. Okay, so this angle, the remaining angle or the angle P is of 80 degree. Okay, now what, the PS is a bisector of angle P. So this means there is a bisector for angle P. This means if this is my bisector, then the angle over here is also 40 degree. The angle over here is also of 40 degree. So you have to find out then which option is the correct option. So if you recall, if you see from the diagram, the what is our QS? So this is my point S. Okay, so if you see the QS is this, QS is this. This is the if you see QS is this, so QS, if you see this makes the angle, the opposite angle to it is a 40 degree. So here the opposite angle to the side QS is this 40 degree and this 40 degree. And if you see, or you can find out the angle over here, this is equals to 180 minus 70 plus 40, which is 70. Okay, which is 70, and so does here, it is also equal. No, this is equals to, if you see what it equals to, it is equals to 180 minus 70, which is 1110. Okay, so this angle is 110 degree and this angle is just 70 degree. Okay, now what, the smallest angle is this. Okay, So from this I can say that this QS is less than the side PQ, or it is also that QS is less than the side which is PS. Okay, so we are taking just this inequality. Okay, so QS is less than PQ, so QS is less than PQ. Now what if you see what is my PQ? So PQ is this length, so PQ is this side, so opposite to this side is the angle of 30°. So this means if you see the angle is of 30°, that means my and this PR, the angle, if you see this side, the PR side, the side PR, the opposite angle is 70°. So from this I can easily say that the PR, the greater the 70° is greater than 30°. So this means the angle, so the opposite side to this 70°, which is PR, is must be greater than the opposite side to this angle, which is PQ. So PQ. So from this I can easily say that QS is less than PQ is less than PR. So my option B will be the correct option. Okay, I hope you understood it. Okay, so let's move to next. What next is, so the correct option was B. So indeed our answer was correct. So let's move to next. Now, if D is any point on the side BC of a triangle ABC, so say D, so ABC, so ABC, so D is any point on the side BC. So D is any point. So say D is over here. Okay, now what? D is any point on the side ABC. Now what? How we are going to solve this? It is quite easy. If you recall the sum of two sides, okay, if you recall the sum of any two sides of the triangle must be greater than the remaining side. Okay, now we know the D's. Just join A and D and see the triangle. In this triangle, triangle 1, the triangle ABD, in triangle ABD we know AB plus BD, okay, is greater than AD. Okay, the sum of two sides is must be greater than the remaining side. And in triangle ADC, so triangle 2, so this triangle 2, in this triangle this AC plus DC must be greater than AD. And both of, if you add both of the two inequalities, you will get, on adding both of the inequalities, you will get AB plus BD plus DC plus AC greater than twice of AD, which is AD plus AD. Okay, now we know BD plus DC is equals to BC. So BD plus DC is equals to just BC. So BC. So AB plus BC plus AC, AB plus BC plus AC must be greater than, so my option A will be the correct option. So AB plus BC plus CA or AC must be greater than twice of AD. I hope this is all clear. That was very quick problem to solve. Now in this, if you recall, for a given figure below, which one is correct? So we are given options. So let's see what options we are given. Okay, so options are here. So we from options we need to just say that which is our correct way to say that two triangles are congruent. So two triangles are congruent, we say in a correct manner that the corresponding sides are equal to each other, which is AC is equals to if you say DE, okay, AC is equals to DE, and CB is equals to EF, and BA is equals to FD. So from this you can just name it, which is ACB. Triangle ACB is congruent to triangle DEF. Okay, the one way is this. Or if you going to like this, suppose I am standing here, I go first to this A to B. So triangle AB I'm writing. So I am on this second side to going to say third side. Okay, so there is third three stick side. So first side is this, and the second two stick side is this, and the three stick side is this. So I am going to D triangle. So DF, so DF to E, so DFE, and AB to C. Okay, and then B to C, so F to E, then C to A, so E to D. Okay, so from this I can easily name it. The triangle ABC is congruent to DFE. Okay, so triangle ABC is congruent to DFE. So triangle ABC is congruent to DFE. ABC is congruent to DFE. I hope this is all clear to you. Okay, so let's move to next and see how we are going to do the next problem. Now, in a right angle triangle, one acute angle is double the other than the hypotenuse is. So, if you recall, in this question, we are given that we have a right angle triangle. Yes, we have a right angle triangle which is of 90 degree, and the remaining angle, two angles are acute angle, and this acute angle we wants to know that one acute angle is double the other acute angle. That means if this is x, then this must be 2x. Yes, then the relationship between the hypotenuse and the smallest side we need to know. So let me give you a small proof for this, and the answer for this is just option B, the double the smallest side. So let's see how we are going to prove that. So in this triangle, first of all, let me make a right angle triangle with this with this as my x, and this is my 2x. Okay, now A, B, C, I am taking this. I'm not just taking, it is the smallest side. So smallest side, why it is the smallest side? If you recall, the side opposite to the larger angle is the longest. So this is my 90 degree, so this is the longest side. If you compare this and this angle, you know that this angle is greater than this. So 2x is greater than x. This means the side opposite to 2x, which is AB, must be greater in length the side opposite to the x, which is BC. And from this I know AC is the longest side. So this means AC is greater than AB is greater than BC. So this means BC is my smallest side. I hope this is clear that why we are saying that BC is the smallest side. Now just produce this CB to D. Okay, now I produce to D, and just add this A, and I am producing this DB in such a manner that DB must be equal to BC by construction. Okay, I am constructing this line BD in such a manner that BC is equals to DB. Okay, I hope this is clear. Now if you see in this triangle and in this triangle, I know DB is equals to BC. Okay, and I know that this AB is common. AB is common to AB. AB is common to AB. AB is AB. Okay, now what? Now this I just produce in such a manner that this line continues. So this line, if this line is just produced further, so this means I know this whole equals to 180 degree and this is of 90 degree. So 180 minus 90 is equals to 90. So this means that this angle angle DBA is also of 90 degrees. So this means these two angles are also equal. So this I can rewrite, or sorry, I can say that angle DBA is equals to angle CBA, which is equals to 90 degree. So from this I can say this line equals to this angle is equals to this, and this is already common. So from this I can say that side angle side by side angle side, both of my triangles 1 and 2 are congruent to each other. Okay, so what if they are congruent? So I can easily say that, let me clearly mention things. So now I can say that, first of all, write me that triangle ABD is congruent to triangle ABC. So from this I can say that, okay, so by SAS we took, okay, so here by side angle side. Okay, now here I can say that DB is equals to BC. Yes, indeed. Now AB is already equals to AB, AB equals to AB. Okay, and from this I can say that this side, the remaining AD is equals to AC. Okay, so AD is equals to AC side. Okay, now what? Now from this we took the so much information about the sides. Now take information about the angles. Okay, so the now by CPCTC we know, we all by construction we know this is of 90 degree and this is already of 90 degree. And now if you see the corresponding sides, the angle made by corresponding side must be equal. Okay, that means AD and the angle made by the two sides AD and AB must be equal to the side in the second triangle, which is AC and AB, which is, that means this x, then this is also x, and then the remaining must be 2x. Okay, so from this I can say this much of information. Okay, now what? Now if you see that what we need to what we are having this as this, that this angle is 2x. Yes, this angle is also 2x. Then if you see the angles opposite to the two equal angle must be also equal. So this means if you recall, if in a triangle I have two angles which is both equal, then their opposite side must also be equal. So this means AD, okay, is equals to AC. I have already know. Okay, now what? Now okay, this information we already have. Now if you see this whole angle, what it is also x plus x, which is 2x. So this from this I can easily say that the angle opposite to this angle, this whole angle, okay, so angle sorry, the side opposite to this angle, which is DC, so DC must be equal to the side opposite to this, because this is also 2x. So from triangle, if I am taking this information from triangle ABC, sorry, ADC, so I am taking this whole triangle, this whole triangle ADC, okay, and saying that this angle and this angle both are of 2x. So from this I can say that opposite sides to them must be also equal. So DC is equals to AC, and I know the DC is the sum of two sides, which is BD and BC, and both are equal in length. That is, DC is equals to DB plus BC, and I know DB is also equals to BC, so this means BC plus BC. This means 2BC is equals to AC, and from this I can easily say that AC, what is my AC? Because this is of 90 degree and the side opposite to that angle is called as hypotenuse. So from this, AC is my hypotenuse and the smallest side was BC, and so this means hypotenuse is twice of smallest side. I hope the proof was clear. So if you are given a right angle triangle and one acute angle is double the other uh, remaining angle, then the hypotenuse is double the smallest side. So double the smallest side. I hope this was the uh, proof for that and you understood it. Okay, so let's move to next. Here let's see one or two subjective questions. Okay, so in this, if you see in triangle ABC given, okay, so my triangle is given such like this. Okay, right to so this is my triangle ABC. So okay, so this whole triangle is my ABC. Okay, now what? Now if you see the BD bisects angle B, so this BD, so the side or the line segment in red, BD bisects angle B. So this means now my this angle and this angle both must be say equal in length, equal in measure. Okay, so both must be equal. Okay, okay, now what? Now and the end is perpendicular to AC, and this means this BD is my also this bisect the angle and it is perpendicular. That means this angle is of 90 degree and this is also of 90 degree. Okay, if lengths of the sides of the triangle are expressed in terms of x and y as shown in the figure, so we have to find out the value for x. Okay, so we just need to find out the value for x. Okay, I hope this is all clear. So how we are going to do that? So just see, let me move to next. Okay, if you see my triangle, the first one triangle is this. The let me uh, over just highlight it. The first triangle is this and my second triangle is this. Okay, okay, I hope this is all clear. Now what? Now just see that this angle and this angle both are of 90 degree. This is the common side and this angle and this angle is also equal. So from this what I can apply is angle side angle. I can say the triangle, say A D B is equals to, sorry, that it is congruent to, so A D to B, we are going A D to B, so A D this is of 90 degree. So similar manner C D to B, so triangle ADB is congruent to CDB. I hope this is all clear. Now what? We know that the both of the two triangles are congruent, so I can easily say that the from this the congruency I can apply that the corresponding parts of the congruent triangle must also be equal. So from this I can easily say that the hypotenuse for this triangle 1, which is AB, this is my hypotenuse is equals to the hypotenuse in the second triangle, which is BC. This is my hypotenuse. Okay, so this is AB is equals to AB is equals to a CB. I hope this is all clear. So from this I can say 2x is equals to 3y plus 8. Okay, I hope this is clear. So this is my equation 1. Now let's find out the next relationship. Okay, and this is a common side. Okay, so the remaining side is just this. So from a CPCTC I can easily say that AD is equals to CD. So AD is equals to CD. From this I can say that x is equals to 2y. So I have two equations. One says 2 times x is equals to 3y plus 8, and another says x is equals to 2y. Let's solve it. Okay, so x is equals to 2y. We know x is equals to 2y, and we also know that 2x is equals to 3y plus 8. Okay, x is equals to 2y. This means 2x is equals to 4y. Yes. So I am using 2x value as 4y. I will get 4y is equals to 3y plus 8. Okay, so from this 4y minus 3y is equals to 8. I know that 4 times y minus 3 times y, what I will get just a single y. So now y is equals to 8. Because y is equals to 8, then I can apply value for y to get x. X is equals to 2 times y, and we know y is just 8. From this I can say that the value for x is 16 and the value for y is just 8. Okay, I hope this clears the question. Okay, now so from this you can easily say that the value for x is 16 and the value for y is 8. Okay, I hope you understood all of the concept and the conditions for congruency, how we used, why we used, how we solved these two equations. Okay, and these all things polished your concept on triangles or the theorems we previously learned or studied. Okay, so that's it for today. I hope that you understood everything. Let's meet again on another topic. So thank you with having me and paying your attention. Thank you.